Hello everyone, and today we're going to do something fun. No theorems today, just an exercise which I've taken from one of my old exams. It's really simple, and we're going to do some, no, you're not going to see it, some hypothesis testing. So, yeah, I'm not going to write it. So we're going to, I modified a little bit just to make it a bit more fun, but this can be applied to any sort of test, and there's different type of hypothesis testing. Today we're going to see one, which is going to be a test on the mean, and we are going to make some assumptions, which are, you could say it depends. You could say they're pretty strong, but you can always find yourself. You can modify it a bit. You can play around with what the data you have to fit the best possible hypothesis test you can come up with. So this is an exercise. We're gonna solve it. It shouldn't take long. And then after that, I will show you some way you can, with actual data. This technically is from actual data, but you can modify this, and you can apply this to every type of hypothesis testing. So the exercise reads: so find Italian wine bottles, claim maker, bottle maker. As usual. Okay, sorry, I messed up. Claim their bottles hold 730 milliliters of wine. Okay, so some and oh god, that's like almost a liter, so that's like less than less than a quarter of a gallon. So some doubtful French wine experts, the exercise may have not read this way, doubt the truth of such claim. So what do they mean? They mean that these French people, they doubt that the bottle actually holds 730 milliliters of wine. So what do? They open 81 bottles. They enjoy the wine, and they measure the how much wine there is in every bottle, and they measure that there are 126 milliliters on average of wine per bottle, and they also measure a variance of 725 milliliters square. Now, assuming, and I messed up once again. Now, assuming the quantity of wine inside a bottle follows, and this is the first kind of strong assumption, follows a normal distribution, fixed a level of significance, test the claim. What is the claim? The claim is, so we're going to start, saying that so I'll try to be as clear as possible. So what do we know? We know that we have n, a random sample of length n is actually 81, that follows a normal distribution of what? Of some mean, mu, and some average, and some variance, sigma square, right? That's what we're told. Now, we want to test the claim. What is the claim? The claim is the claim made by the Italian company that the bottle holds 730 milliliters. So we know we want to make to construct our hypothesis testing is mu is equal to mu0 equal to 737 milliliters. On the contrary, and we can select our let's say alternative hypothesis. This is null hypothesis, alternative hypothesis, So I'm assuming you guys know what these are. Okay, mu is, and we can just say that it is not as important. It's less than mu0. Okay, so far it shouldn't be, let's just say it is different than mu0. Okay, so what do we know? Well, here a pretty interesting fact. Now we know that the sample mean, which I'm going to define like this. What is this? This is sum of the realization of the random variables is equal to 726, right? Yes, that is the measure, the quantity measured by the French doubtful and envy people. Now, because obviously they don't believe Italian wine is better. Now, their sample variance is equal to 6, and this is the adjusted estimator for the variance. So it's this one, and is equal to, is equal to 700 and 625 squared, right? So what do we know? It would be interesting to know if we want to, sorry about that. We want to construct a pivot statistic. Now, what is a pivot statistic? I.e., a statistic that depends only on what? Obviously, being a statistic on the random sample, the random sample, and the parameter we are trying to test, i.e. mu, the mean, right? So we want to construct a Tn that is going to be defined as a function of the random sample. Sorry, I already messed up. And our the parameter we want to test. Now, the problem is we don't know what mu is. We're trying to test it. We don't know what the variance is. We know what, however, we don't know what the sample mean and the sample variance is. So what we can construct is, we know that, first of all, so let me proceed with a remark. So we know, and we can easily prove that the sample mean follows a normal distribution of mean mu and variance mu over n. Now, it's very simple to see. You can simply as xi follows normal. Now you know that the sum of n, a normal distributed random variables, is a normal distributed random variable whose mean is n times the mean, and whose variance is n. You also sum the variances, right? So n times that. Now, the moment you multiply this by 1 over n, you need to multiply the mean, because the mean is, remember, it's linear. However, the variance is quadratic. So you do this, and here goes an n square, which cancels out, and you're left with sigma squared over n. Now, that was a very simple, just obviously, if you want to be formal, but it's an exercise, but I can help you guys. Sorry, I'm a mathematician. You need to prove these formally. Okay, now, the sample variance, once again, under the assumption that the random sample is normally distributed, will follow, the sample variance multiplied by the degree of freedom divided by the variance will follow a chi-square, call whatever you want, of n degrees of freedom. Okay. Now a chi-square is a defined as the sum of independent Gaussian random variables to the square. Okay. Now, what is more interesting is that what we can define is, so ideally we're looking for a statistic of this type. Sample mean minus, if you could subtract the average and divide by the variance and the degrees of freedom. So this would be so if you have a normal distributed random variables, you subtract the mean, you divide by the square root of the variance, you get a standard normal distributed random variable. However, this is unknown. We're trying to look for a statistic, so a function of only the random sample and mu. This would be a function of sigma squared, which we don't know, so we cannot use this statistic. This is not a pivot statistic. However, we know, let's call it a memo. So obviously, I'm trying to explain every step. In a real life example, I would have finished already the exercise, but obviously, what's the point in just me showing off, right? If we have, so let's assume x is normally distributed, standard normally distributed, and y is a chi-square of n degrees of freedom, then the ratio of a standard normally distributed random variable over the square root of a chi-square divided by its degrees of freedom will follow a t distribution of n degrees of freedom, right? Now, what do we know is that of n minus 1, sorry. So what do we know is this, as we just said, follows. Let's actually write it this way. This follows normal distributed random variable, a standard normal distributed, right? If we divide by a chi-square, right? So if you divide by n over sigma square, okay, divided by what? By its degrees of freedom. So we need to divide by n. Okay. Then what we get, sorry, this is inequality, obviously. My apologies. So let me write this times, this would be, okay, times sigma over Sn squared. They simplify, xn minus mu, the n goes here, divided by, obviously, this is the standard deviation, so the square root of the variance. This follows a t distribution of n minus 1 degrees of freedom. Okay, now we have found a pivot statistic, which is perfect. Now it's very simple. Now, under the null hypothesis, mu 0, h0. We have, let's call this bad boy here t. T follows, t is, oh sorry, this would be always sample, the sample mean. This would be n. Why did I put an n? Sorry. Why did I put an n here? Yes, okay, yeah, yes. N. Yeah, you can just keep it here, to be honest. It's cleaner this way. So this would be 730 mu 0, because we're under h0. Okay, follow t minus 1. Now, our critical region of level of significance alpha, what is that? This would be all the realization of the sample, of a random sample, such that t is in between t, let's call it t critical is greater than, this is how, because the just a second, let me write it down, then I'll explain. Still haven't learned how to do two things at once, but maybe because it just speaks to a man. Now, so you know that t is a symmetrical distribution. So we're basically saying our critical region, meaning that we cannot. Okay, so I just realized I've written something very stupid. So this would be minus. This would be a this way. So basically, because of the symmetry of, as I was saying, of the t distribution, t. Okay, right? So this would be our critical region, meaning that all the values that follow that land outside the critical region, then we have no reason to reject the null. Let me write it down. This implies all the values for all of the values of t that fall outside the critical region C alpha, we have no let me write statistical reason implied by the data to reject the null hypothesis. Okay. So, meaning that if we now, and by all values of t, I mean all values of the, all realization, obviously, of the random sample, such that obviously t depends, as we said, also on the random sample. Okay, so that's what I mean by that. So if you do the math, and obviously as a mathematician, I hate doing computations, so I will not do them. I will just give you the result. Obviously now you know that if you take the realization, you know that the sample mean is, we said 726 minus 730, which is h0. Now the square root of 725 divided by the degrees of freedom, which is 81, to the square root. This is minus 1.44. Now we know that t of 0.05 n minus 1 degree of freedom, which will be t of 0.05, level of significance of 80. If you look at the tables, this is equal to, this way would be equal to 1.9901, meaning that if t critical is larger than 1.99 or t critical is less than 1.99, then we fall inside the critical region. However, we fall outside the alpha. There is no reason to reject H0. What does it mean? It means that the Italians win. There is no sufficient reason to believe that the average, the quantity of wine inside the bottles is significantly different than what it is claimed at 730. What does it mean? It means that the French were wrong, and with the data you have, building this statistic, you have no reason to believe that actually the Italians are trying to scam you, which sounds pretty unrealistic. I'm Italian, by the way, so I can say that. But obviously, I'm just messing around. I'm just trying to make it more fun than it is. So now, I will end it. I think I've been talking for too long. But one thing I want to say is, you can make this type of reasoning for anything that is completely different, like anything that assumes data. And you could say, okay, but what if I don't have this hypothesis? Well, you could try at this point. You can try to use a asymptotically distribution of your random sample, as long as all your random variables are independent and identically distributed. Then you can always use the asymptotical behavior of by the central limit theorem. You know that ID of whatever distribution, then sample mean minus the average divided by its variance. Sorry, I think it's better to say that. So minus its mean. Let's write it this way, because mu is misleading. Minus its mean divided by its variance, square root of this variance, follows asymptotically, that's YVA, a normal distribution, standard normal distribution. What does it mean? It means that it converges in distribution. So means that the limit of the distribution of this guy, which let me call it phi n, okay, as n goes to infinity, is equal to f of z, where z is a random variable, normally distributed. So you can always do that if the assumptions are good enough. And yeah, thank you for watching. I'll see you in the next one, people.